Hello and welcome to my channel. In this series I take you through past VCAA Maths Methods exam questions and provide you with full work solutions. In today's video we'll be going through question 13 and question 14, the multiple choice questions of the 2020 exam 2. That's the VCAA exam. As always I'll invite you guys to attempt these questions first before watching the solutions if you haven't already done so. So question 13 reads, the transformation t r squared to r squared that maps the graph of y cosine of x onto the graph of y equals cosine of 2x plus 4 is. So what are these transformations? So transformations, first step that I'm going to do is I'm going to rearrange this form here. So what we're mapping to could also be expressed as cosine of 2 times x plus 2. Now that's an important step as the order of transformations has a direct impact on the result that we'll get there. So we can see, we know the order of operations is dilations and reflections at the first priority, and then the second sort of priority is the translations, vertical and horizontal. So like this, what we can say is we can say that the transformations t, x, y can be expressed as a, so this 2 here is a dilation of factor half in the x direction. So that's expressed as a half in that position there. We know there's no dilations in the y direction, so that stays as 1. We've got x, y, and then we'd have a translation of 2 units left. And 2 units left can be expressed as minus 2. So this here would be an equivalent or an acceptable order of transformations. But if we look through, we can see that some of these options actually change the order of the transformations. So A, C, and D look a little bit strange. They may be acceptable. But let's first examine B and E. Since they are in the same form, they don't have additional sets of brackets. So we can see B has the same dilation and reflection matrix there, which sometimes is denoted by capital A, X, and K, for example. So that's the same. However, this has a translation of 4 units, so we can rule out B. E, on the other hand, has a dilation of a factor 2 instead of a factor half, and also the translation's in the wrong direction there, so we can also rule out E. So if we take what we had worked so far and write down an equivalent by changing the order of transformation, so we want to keep this dilation reflection matrix the same. However, we're now going to insert an additional set of brackets. What effect would that have? So x and y has to stay the same there. However, if we're changing the order of transformations, this goes from minus 2 to minus 4. And that's sort of reflected in the original form as well. So you can see the usual approach would be factor out that 2 there, and then when applying the correct order of transformations, this is what we would get in green. However, by factoring in the translation first and then the dilation, then this is what you end up getting. So this here looks like option A, is it? Yeah, it looks like A to me. Great. Option A. Moving on to the next question. Question 14. The random variable x is normally distributed. The mean of x is twice the standard deviation of x. If the probability of x is greater than 5.2 is equal to 0.9, then the standard deviation of x is closest to. Great. So there's a couple things we can write down straight off the bat. So we know the mean is twice the standard variation. In other words, mean is equal to 2 sigma, like that. So that's an important expression. Obviously both of these are for x. We also have this probability that x is greater than 5.2 is equal to 0.9. So those that know me know that I like to always draw out a normal distribution to annotate and make it a bit more clear. So we know if it's greater than 5.2, then we're going to have 0.9. So in other words, we know this area, it's greater than something, will give us 0.9. So it has to be to the left of the mean. So this would be 5.2 here. And this is our unknown mean of x. In other words, what we could have also have, what we also know from this is that this error here must be 0.1. So in other words, the probability that x is less than 5.2 is equal to 0.1. So where do we go from here? We've got the mean that's unknown and also the standard deviation that's unknown. So two unknowns with only sort of one expression, we aren't able to solve that. So this is where we'll have to use both our calculator and the standard normal distribution. So if again I draw another distribution, we know this one would be for z, the standard normal, and we know that we've got a 0.1 area here, and we know the standard normal has a mean of 0, so mean of z is equal to 0, and the standard deviation is equal to 1. So in this case here, we know the area, we know the mean and the standard deviation, so all we need to work out is what this value is here, and then we can use an equivalence by the z-score formula to equate what this value would be here on the z, or the standard normal distribution, with our particular x distribution. Once we have that, we're then able to solve for the mean and the standard deviation. So this is where we'll need to use the function on our calculator. So I've just used the inverse norm function with parameters 0.1 to 0.1. Your calculator may be slightly different. In terms of the calculator I was using, it needs to use a sort of approach from minus infinity up to the value. However, I know some calculators are smart enough where you can put in 5.2 to infinity has an area of 0.9. But what this notation says is that from minus infinity, I guess using the z-score, from minus infinity up to a particular value, has area of 0.1. So that's what the 0 and 1 is, the standard normal parameters there. So doing this gives us a value here in red of minus 1.28155. Now we know that there's an equivalency here between this value and this value. So we just need to then utilize the formula that z is equal to the mean minus, whoops, that's not right, the x minus the mean on the standard deviation, where we know that the mean of x is equal to twice the standard deviation now. So in other words, we can say x minus twice the standard deviation of x is equal to the standard deviation of x, and we can start subbing in some values. So the next line here, we know that z value was minus 1.28155. It's going to be equal to 5.2 minus 2 sigma x over sigma x. And if you wanted, you could just put this in a solve, swap out sigma x for just a variable, say x, and solve for that. In doing so, you'll end up getting sigma x is equal to approximately equal to 7.2378, which looks like to me that is option A here as well. Great, so this one's definitely pretty tricky. There's quite a lot of steps, and from what I've seen, a lot of students aren't always as confident using functions such as inverse normal. So let's have a look at the examiner's report for this one. So you can see question 13 here was answered quite poorly, with only 26% answering correctly. The most commonly chosen answer was actually C. So you can see what we have in green is very similar, except there's an extra set of brackets. So that's sort of students not recognizing that the difference in the order of transformations and its impact that has on the overall set of transformations. So you can see in the comments there, they recommend to first rearrange this cosine function by factoring out the 2. Clearly states what these transformations are. So we've got the dilation of factor half from the y-axis and the translation of 2 units left. And then they do an equivalent expression to get the correct answer. To question 14. So question 14, 44% answered correctly, so a bit better. However, still, less than half, so not answered very well by large. And their workings show a sort of a similar approach to what we've done, maybe just a bit more concise, but I think it helps to sort of draw out what these distributions look like when solving. So hopefully these solutions have been clear and enough for you guys to wrap your head around. That being said, thanks for watching the video. If you got something out of it, then I'd appreciate if you guys leave it a thumbs up or share it with friends or classmates. If you're new to the channel, then please feel free to subscribe for more content like this in the future. I make videos at least once a week. Lastly, if you've got any questions you'd like to see answered on the channel, then please send me an email at yourmathquestions@gmail.com. Thanks for watching, guys. See you in the next one.